How's it going, everyone? Welcome in. Happy Saturday. We're going to be continuing our PyTorch transformer. We hit a few shape challenges on our output, and we need to make some adjustments. I think there's a thing that I want to do with the batch to get a better batch. I want to make it generator with the batching, and then we just need to get the proper shapes from our outputs in order to make it work. And I think we're going to do it. I'm pretty confident. I did a little studying. I think we've got the right path ahead. We're gonna give it a shot. Let's take a look at where we left off yesterday. This is exactly where we left it, and we just need to make some adjustments. So we have a problem here. We had an out of range problem, which we can fix. And I also want to convert to a generator with the yield. So we get a yield operator there. Instead of just returning features and labels, we're gonna yield it. So it's a similar thing, except for it has an opportunity to miss data, and I want to do a full coverage. So this, hey Hadar, good to see you. Hello, welcome on in. Happy Saturday. Hope you have a good plan for this weekend. Hope things are going good for you, and you had a good week. Welcome on in. Good to have you here. All right, so we got a plan. We've got a pretty good plan right here. All right. So I want to make this adjustment because that's going to fix some of the problems. And then I'm pretty sure we have to make a few small minor adjustments up here. And not these things. Around here. Let's see here. Let's go back up to the top. Maybe the attention. I don't know. Somewhere around here. We'll figure it out. I know we're missing something because our outputs seem a little weird to me. They seem just a smidge weird. So I think we can figure it out. I'm pretty sure we can figure it out. Let's start off with doing the batch adjustment because I think that's pretty straightforward. So what do we do here? Okay, so this creates a whole bunch of essential segments that we can use. The thing is, though, this is missing some data, so I want to convert this into a generator. I think we can make it. Hey, Snot 123. Oh, welcome on in. Good to see you. Happy Saturday. Good to have you here. All right. So I want to convert this to a generator. So what we need to do is convert this into the entire maximum data set. And so let's see, just do a full epoch. So all samples in epoch, right? Maybe number of samples. How about this? Total samples, a little bit better. So we're gonna go training data set length, which I'm pretty sure is that right there. So I don't know why I'm making a whole nother variable for it. It's fine though, it's fine. And then instead of having it batch size, we're going to make it the full size. So that way we can fully cover. And maybe it shouldn't be randant. Right? It needs to be... We need to do something different because I don't think it's randant. Hey, Rishu! Good to see you. Welcome on in, Rishu Kumar. Good to have you here. Happy Saturday. Hope you're having a good weekend so far. Good to have you here. All right, so... Let me change up the music there. Okay. I don't want to do random. I want to get it doesn't have to be random anymore. It just needs to be a linear space. And then if we could do like a shuffle of something, right? So let's think this through. So I want every value in an integer, like all the way up to the top. And then I want to shuffle it. So that way I get 100% data coverage. Because I don't want to miss anything, right? Because if we're going to do like a whole bunch of epochs, we don't want to miss any data. Hey, I was going there, 7LA. Good to see you. Hi, how are you, man? Doing good, thank you. Can you share diagram or steps for beginners? Yeah, for beginning to inference. Absolutely, we did it. We built this. All right, so let's see here. This is what we did. So we have the diagram here. Really easy. The chat was happy, right? To input text data. We convert all of these words right here into numbers because AI, it likes numbers. It does. It likes the numbers. So we convert these into what they called tokens. Tokens is another word for number, right? So the is going to be referenced by the number 1. Chat is referenced by the number 2. Was 3, happy 4. These are now representative of these words. We convert these numbers into an embedding, which is just a matrix, right? It looks basically like this, you could say, but almost perfect. You could have an embedding that looks like this. It's a matrix, and it is the same length of the vocabulary of your total data set. So say we only have 4 words, right? We have 4 words. So we have an embedding layer, and then you assign each of the indexes of your words into a row of an embedding. This gives you sort of a whole bunch of features. The idea is we want to derive meaning of the words as they are shown to the network. So these are learned weights, but they're only a token at that point. So now the word the is this right here. Chat is 0.3, 0.01, and 0.8. All right, so now we've got our representation that's ready to go for the AI. But we can go a step further. If we want to scale it up, we can add something called positional encodings. These encodings are typically like sinusoidal or some sort of geometric shape that can represent a position. We append these numbers. Is it random numbers? Yes, these are. So these numbers right here will be random. They will be random, yeah. And as we do back propagation later, which is just the model learning, it's the learning process of the model, these numbers will slightly update based on where they are being seen in representation to other words. So it basically creates the meaning of the word chat, for example, which is right here. This is the word chat. That is now represented as a number. And so this is what's called an embedding. It's just another fancy word for a bunch of numbers, right? Then we add the positions. Now we're ready to train. We take these numbers and we multiply them by 3 different types of matrices, the query, key, and value. So you've got a linear layer, another linear layer, linear. Basically, it means a matrix. And these numbers are also random. 1, 2, 3, whole bunch of random. And then this gives us what they call projections. It basically means it's a matrix multiplication. So we multiply all these numbers to all these numbers up here. And we do the same thing for key and the same thing for value. And so we get essentially 3 outputs. And then we take these 3 outputs and then we put them into this, let's see here, number 5, right? Here we go. We merge them basically. We merge them all back in. Basically, we do math to them. we matrix multiply them with each other. So Q and K are right here. This @ sign is a matrix multiplication. So you know what we did over here when we did the matrix multiplication? To create these additional matrices? Well, we're gonna do it again. That's all what AI is. It's a whole bunch of matrix multiplications. Weights is random too. Yes, you're right. Ask as many questions as you want. This is the whole reason we're here. And the good part is, as I'm explaining it to you, I get some benefit too, because I'm in the process of memorizing it. Hey, Loons, good to see ya. Happy Saturday. Hope you're having a good weekend so far. Hey, everyone, good to see you. Welcome on in. All right, did we post on our general? I don't know if we did or not. Okay. Oh, hey, Loons, I missed your message. I'll have to read it here in a minute here. Let me do a quick little link share. Copy, close. All right. Here we go at every O-N-E. There we go. Okay. Hey, Derek, good to see you. Welcome on in. Good to have you here. We're just doing a quick little walkthrough of Transformer, which is what ChatGPT is, right? We're making our own, and we succeeded in building it. The thing is, we have some bugs because we wrote it ourselves from scratch. So we have a few problems to solve, and that's the plan for today. If we can solve it, I'll feel so good. I'll feel so good. Hey, Clips Merge. Whoa, how's it going? In Quantify Quantum, good to see you. Welcome on in. How's it going? Hope you're having a good Saturday. It's the end of my subscription today. Oh, Loons, no way, really? Thanks, just got back from the hospital. I had a procedure. Oh, Derek. Well, I hope you're okay. Hope you're doing good. Hope you're feeling okay. Hope the procedure fixed all the problems. Made it way better, right? Made it way better. So we take the Q and the K, we matrix multiply them. This dot T means transposition, which just means rotating it, right? So we spin the matrix and the numbers all rotate. Then we divide it by the dimensions of our embeddings. So like this is 3, right? So this will be 3 because you see 1, 2, 3. There's 3 elements here, 3 features. And we take the square root of that, which just makes the number a little bit smaller, right? All good, just tired. Might drop off stream to rest. Hey, sounds good, Derek. Take your time to rest. Where I found used resources in this live. Where I found used resources in this live. What? Wait, what? At 7. What? What do you say? If you're looking for the source code, it's on GitHub. So if you want the source code of where we're currently at, or do you want like this specific link here? I can share it to you. Export link, and I'll put it here on our Discord under link share. All right, I need to catch up on these things. Oops, that's the wrong one. That's the wrong one. Nope. Copy link. Edit, paste. There we go. All right, perfect. Thanks. Yeah, absolutely. Wants to know what is used and where to get. Yeah, okay, got it. Yeah. Thanks, not. Appreciate it. All right. And then we do an attention mask, which just basically multiplies the numbers by 0 on a diagonal, basically hiding part of the input data. So you like blur it out, which is okay because typically we're doing a correlation coefficient matrix for the most part with a little bit of softness in there. So it actually ends up being perfectly fine. You don't need to worry about it, it's just perfectly fine. Do some softmax. Then you do another matrix multiplication with the same data again after the softmax. NP did my hard thinking for the day. You did it. Thank you. You achieved the objective. Time for nap. Nice. That's what I like. I like sleeping. Sleeping is like one of my favorite things in these days. I'm really liking it. Multi-headed attention, which is basically doing this a whole bunch of times if you have multiple heads. Hey, Savon, good to see ya. Welcome on in. Hope you're doing good. I saw you post a message on Discord. I haven't read it yet. Just went live. I'll have to take a look at what you guys put up there. I need math to build LLM. And sorry for my English. Hey, no worries. You're all good. You don't. Oh, hey, Loons. Hey, you Hey, Loons. Thank you. It's a nice surprise. Yeah. Yeah, that's great. It's great. I appreciate it. Good to see you. Well, I mean, good to chat with you, I suppose. Good to chat with you. Loons, thank you. I see you did the channel. You did the channel membership. Hey, all right. That's fantastic. Thank you. My gratitudes. We should all start learning Mandarin. Oh, right. You said you started learning Mandarin. That's right. I saw it as a notification on my phone this morning, and I was like rushing to get ready and, get ready for the day. Good to see you all as well, Steven. Nice. $3 disappeared. You did it, Loons. Thank you. That's so nice. Thank you so much. Then you can concatenate the heads if you did multi-headed attention, right? We're not doing multi-headed attention right now, though we might decide to do it later because it adds it. What is it? It does. It creates attention across the parameters differently than what we're doing it right now. It creates multiple softmax outputs, and then you concatenate them at the end. And then you run it through feed forward. And in this case, what they describe as 3 feed forward is simply a bunch of linear layers, more matrices, right? A whole bunch more matrices with an activation, potentially a dropout if you want. Hey, Code Langton's Entropy, good to see you. Welcome on in. You've managed the impossible. Oh, what did you do? You successfully upgraded the Hyper Manager default Ubuntu from 2022 to LTS. Oh, wait, LTS is 2024 maybe? I have been trying for years and finally found the loophole in Hyper-V shenanigans. All right. Code Langton's, good job. You did it. It took you a while, but you persisted and you succeeded. Good job. And then I think that's mostly it, right? Yep. And then you do a linear output, so that way you can target your total potential token alphabet. Your alphabet in this case is which tokens you have, right? So you've got tokens here. So the total output would be a projection of 4 possibilities. What about my question for math? Is it necessary? Oh, thank you for re-asking that question. Thank you. Okay. So you don't need it. You don't need to understand it, because I mean, I didn't fully understand it and I'm still successful when I started this many years ago. It does help, especially if you're innovating. However, if you're just sort of leveraging the system directly, the math is pretty basic, right? As you can see here, the most math that we did was right here. And it's just more of the same. It's the matrix multiplication between 2 matrices. Oh, we've been doing that already. And then we do a square root of the dimensions and some division here. Those basic elementary math, right? And a tension mask basically is another matrix multiplication with a bunch of zeros on the corners. And the softmax is just a scaling factor, nonlinear scaling, which just converts all the numbers into, it shrinks them down, it shrinks them. So that way, all the numbers will equal 1. Basically adds all the numbers together in the matrix, and then it divides all the numbers by that value that you've created from the addition. So it scales it. That's it. That's the worst. That's the worst of it right there. It doesn't get more tricky than that. And now you've built ChatGPT right there. Look at that. Normalization. Oh, right. Hey, Manotor. Yeah, I forgot about the layer norm. So that is going to be around here. I forgot to put that in. Thank you for reminding me. We could do that. We could do that here. All right, layer here. How about this? We'll just put it up here. All right. We do a norm. So a norm, which is out from this layer norm out here, and you add, I believe, the original input. Hey, Bonzupi, good to see you. Welcome on in. Sleepy, you'll probably fall asleep soon. Sounds good. Sleep is one of the best things in the world, isn't it? A really good technology. Well, it would be great if we didn't have to sleep, but boy, isn't it nice? Isn't it nice? Lull me to sleep in your duet or docile tones. Yeah, my docile tones. All right. We'll see how we do it. We'll see how we do. So we just walked through where we are today. If you're building ChatGPT, it's obligatory to sprinkle in some goblins and gremlins in the LLM. Yeah, we got to make sure to do it. It's mandatory. All right, fine. We will. We'll do it. All right, Bonzupi, because you asked. All right, let's do it. So in the code comments, don't delete this, Bonzupi. All right, don't delete this, but we need to be sure to say goblins and gremlins. All right, right there. We added it in just for you. Right there. Let's do an arrow. I think an arrow would be good. There we go. Goblins and gremlins. Let's do another arrow. Perfect. And we'll do some inside arrows. Perfect. The other direction. Left arrow. There we go. Wait, you're misunderstanding the thing about goblins to me. Wait, you're misattributing. Well, you recommended it though. I wouldn't be doing this unless you recommended it. This is mostly because of ChatGPT, right? So ChatGPT has a lot of goblins and gremlins. Token output due to training. This is a real thing. So, Bonzupi, because you asked for it. Oh, wait. Did I read that wrong? Wait. Somehow now it's ChatGPT 5.5 truly. Wait, you're building ChatGPT sprinkle. Oh, you're right. I read it wrong. Sorry. Wait, okay. Code Langton's entropy. Oh, I just read it wrong. Here we go. Hold on. Let me type your name properly here. ENTROPY. Code Langton's entropy. There we go. All right. Sorry about that. Oh my goodness. It was Code Langton's entropy idea. Thank you for the correction. Make calculations if I want the badge. For you're a member, you need 144 euros. Oh my goodness. Loons, that's an expensive badge. Deserves the attribution for this unit. Yes, I'm proud of this contribution. You're proud of it. I made history today, guys. You did it. We're going to train it. It's going to happen right there. Right here. Right there. You need to go. All right, loons. Thank you again for the membership. Oh, also, Aziz, thank you for the subscription. You joined the right channel for software engineering. We're currently building ChatGPT. We're making it a good one. We're adding in the goblins and the gremlins too, right? Like code lengthens entropy recommended. Steven, you could show the edgy post where, if you want, is it? I could? Okay. Let's do that real quick. Did you put it in? Here we go. Let me see if this works. Here we go. Okay. Oh, wait.
It's the world's first robot combat league. Engine AI calls it the ultimate robot knockout legend, open to teams worldwide. Universities, companies, and research labs all get a T-800 humanoid robot completely free. This robot throws side kicks and lands a 360-degree aerial spin. After every knockdown, robots have 10 seconds to stand back up on their own. The season runs through December with 16 teams.
Oh, it's a TV show.
Tournament. The winning team earns a gold belt worth $1.44 million. Would you rather see human athletes compete, or are robot fighters the future?
Is this real?
While you watch human fights,
hey, Savon, is this real?
Robot Combat League. Engine AI calls it the ultimate robot knockout legend, open to teams worldwide. Universities, companies, and research labs all get a T-800 humanoid robot completely free.
Okay, I think so. The company is real. All right. The more we know, ultimate robot knockout legend is a diabolical name. It is. And AI engine. All right. The more we know, you guys.
Earns a gold belt worth $1.44 million.
Wait.
Would you rather see human athletes
Dang. All right. That's crazy. Savon. Whoa. Hence, learn Mandarin. All right. I know, right? Have you guys seen the movie and the TV series Firefly and Serenity? Have you seen that? You know, they speak Mandarin in that quite often because China. They do. It's a great show. I love that show. It's only one season long. It's only one season and it's worth it. Only 14 episodes and a movie. You learned. Oh, you need to reach Serenity. Oh, you need to reach Serenity. Gotcha. You need to watch it. Even better. Best live action series. It will be Bonzupi. John Cena speaks the best Mandarin. Does he really? He's a good Mandarin speaker. That is pretty impressive. All right, so I need a linear list. So if I'm going to jump back into this, I'm going to be updating my batch here to be 100% data covered. Right now, there's no coverage. It's random. It's RNG. Autocorrect is doing me dirty all the time. Yeah, I have that problem too. John China. John China, yeah. I think they may be doing a season of Firefly soon. Wait, I think they may be doing a new season of Firefly soon, actually. All right, Bonzupi. I heard they are doing something, and I thought it was going to be live action. It is going to be animated. They have it. I think they have basically everything, and this process is starting right now. They've got the funding, they've got permission, and they've got the voice actors are all in. All the original cast. So it'll be the original cast voice acting it. They've let us on before. They have. So we'll see. I'm going to watch it. And I'm also watching a lot of anime anyway. I don't know why. I mean, here's what the deal is. I really wanted the live action show to continue onward. I did. Because it started out that way. Changing formats is going to take me time to get used to it. However, I mostly only watch cartoons anyway. I only do it anyway, so it'll be fine. I just need to get used to it. I'll need to get used to it. All right, so I want like a line space. Let's do this. Python import torch. All right, torch dot line. I think it's line space. Is it lin space? Let's see, Lin with an S here. Yeah, okay, there we go. Can we do like 10, 10, something like that? No, how do we do this? 10 as a tuple, maybe? 1, 1. What is it asking for? Received an invalid combination of arguments. Got tuple, but expected tensor, start, tensor, and tensor. Okay, let's look this up. Oh no, oops, I didn't want to do that. CD, desktop, and then we go to transformer. All right, Google, PyTorch. Hey Kyle, good to see you. Welcome on in. Happy Saturday. Hope you're having a good weekend so far. Anyway, the reason I speak hybrid of English and Mandarin is because, think of the hunters, they're predicting that the most prevalent cultures and languages in today's society will become their homogeneized in the future. Yes, combined just like they did in Firefly, right? Just like in Firefly, they combined English and Mandarin in that show. Obviously, it was mostly English, but they did a lot of Mandarin. You agree? It's going to happen? Best new cartoon is Smiling Friends. If you know, you know. I need to see it. I haven't seen it. I'm curious about it. Can you create games? Hey, Aiden. How's it going there, Aiden? Welcome on in. Good to see ya. Happy Saturday. Yes, we can. We can make games. We sure can. We need to get our batch shapes proper first. So I need to get 100% coverage for every epoch. So I need to create a uniform random. All right, PyTorch, create a uniform random. See. So how do we do this? I need to say this better. Create vector of complete numbers 1 to 100 and shuffled. All right, let's see if we can do that. If Firefly were made today, I think they may end up throwing a bit more Spanish into the mix. Oh yeah, they would, right? They might, yeah. That makes sense. I think you're right. Hey, Theo, good to see you. Welcome on in, Theo. I see you use PyTorch a lot. Yeah, can you explain why it is essentially essential to many of your builds? Yeah, because we're doing AI. we're doing AI. We're building a mini ChatGPT, and we've been focusing on becoming a PyTorch expert. And to do that, we have to build a lot with PyTorch, right? We have to use it a lot. Hey, Chitter Royal, good to see you. Welcome on in. Happy Saturday. Aiden, hello, Chidu. Good to have you guys here. All right, so let's see. So an A range and then a random permu. Ooh, all right, there we go. That's what I want. Check this out right here. Okay. Or step by step. No, we're going to do a one-liner. Python, import, torch. There we go. Yeah, that's what I want right there. Look at that. Okay. Indices. Index is equals. We'll do torch, and then we need to set it to, let's just say samples, like that. So it needs to be 0 to samples, and the permutations need to be samples. So this gives me all the indices. Then we can get rid of that. And now we need to, let's see, we need to calculate the total number of batches, maybe. Can I use PyTorch in CPU? Yes, you sure can. In fact, that's what we're doing here. We're using it on the CPU. We do have a GPU accelerator, though, a really good one. We have a really good one. It's really powerful. But for the most part, since we're doing such small models, the CPU is fine. Theo is like, oh, I always use TensorFlow. Interesting, thank you. Yeah, TensorFlow. That was one of the earlier frameworks, right? So before we had TensorFlow, we just had regular math, and that's where I learned AI. Then TensorFlow came out, and then we had Keras that sit on top of TensorFlow. They merged them. Now they're kind of standard as a combo, so you always use Keras, right? Then they came out with PyTorch, which Facebook Meta created. Now, since everyone loved PyTorch so much and it overtook TensorFlow, Google has a new framework called JAX. Yeah, that's their answer to PyTorch. So that might be the next one we do. We might do Jax next. Okay, this is so cool. All right, so thank you for the hearts, appreciate it. I just bought Ford truck for $1,500. Nice. It's a good deal. Hopefully it works. Could probably get a detail and sell it for $5K. Ooh, you are so good at that. You're like an entrepreneur for everything you do. Always thinking of profits. I talked to a guy down and he called me back to 3 hours later and got it for a steal. Nice. Good job, Kyle. Jax is an alternative PyTorch? Yes, it is. Yes. Jax from Google. It's Google's answer to Meta's PyTorch. So basically, they're like, oh, that's actually a really good design pattern. We're going to copy that. And they should have, because it's a good one. It does exactly why the power of Python is so good. It's so good. It's amazing. It's amazing, you guys. It's amazing. Let me go back to my business here. Random permute. Yeah, okay, perfect. Okay. So let's do 1010. It needs to be 0. There we go. Yeah, that's what I'm looking for right there. Look at that. Okay. All right, so I'm really happy with this. Now we need to create the generator. Now we have to create the generator. So let's see here. Let's see. Oh, hey, how's it going? Ifty, hi. I really like your torch videos. Thank you. That's great to hear. Can you please organize your YouTube playlist so that it is easy to follow, like similar to a playlist course? Absolutely. Yeah. So we should do that. So if we go to Steven on YouTube, then we see here, let's see here, courses. So I do have courses here. I also have some playlists. So I got some playlists right here. Do we have PyTorch in here? We do have some PyTorch right here. These are the early days of PyTorch when we were just walking through the basics. So these are really good getting started tutorial right here. And we also built a game in PyTorch. And we'll be doing, we did a click prediction. And right now we're doing a mini ChatGPT. So we can add even more. So there's more playlists to be had. More playlists, you guys. You're gonna go detail it, either flip it or wrap it in your branding. Not sure yet. Advertisement. Yeah, that's a good idea. So that way when people see, they'll be able to know. Oh, flip profit, you guys. Flip profit. Okay. So let me think about how I want to do this, because I've got a series, and so that I want to sample this. So I've got the full range here. So, okay. So I need to have a position. Position equals 0. Current position. So then I can increment. So for batch in batches, I think. Yeah, so instead of doing this, we're gonna change this up. This is for batch in get batch. There we go. And it needs to be feature target here. Perfect. Okay. So this looks good here. So now I've updated that, and then I need to yield the feature and labels like that. Okay. Okay. All right. Then I also need to set these values. There we go. So far, so good. Now I just need to take the indices and get a slice of the indices. So let's see. Let's do current. Let's see here. How about batch? No, I've already got batch defined here. Range. Okay. So how do I want it? So I've got the current batch was a number. Oh, and I probably don't need position. So I don't need to worry about this. So I just need to slice the indexes here. Here we go. All right, now we're on the right spot. So let's slice it. We're going to say batch, colon, and then we need to say, that's the current batch position. And then there's a batch size around here somewhere, right? Do we have a batch size? Where's that at? Hey, SSH, good to see ya. Hey, Steven, how's your day? We're doing good. Good Saturday so far. Got a question. How can I learn coding as a project oriented rather than just solving coding questions? Yes, that's the best way to do it. It really is. It's the number one. What you need to do is decide what you want to build. You want to build something, right? Decide what that's going to be. It could be something really simple initially. Doesn't matter what it is. And it's very important that you do not study ahead. Do not prepare for it. Just start building it. Now, when you jump in, say you're going to build a calculator. Let's keep it really simple. You're going to build a calculator. You don't know anything. You know nothing. Like, all right, we're going to build a calculator. Have no idea how to do that. So start thinking that, okay, I've got an open file here. You open an empty file here. So now I've got an empty code file. I don't know what to type in there, right? So what I'm going to start doing is I'm going to start Googling or researching next. Like, okay, I'm going to build a calculator and I want to add two numbers together. All right. Like 1 + 1, something like that, right? You might open up let's see here. Split a window, say Python, say 1 + 1. Okay, calculator. A = 1, B = 2, A + B. Oh, there we go. All right, so far so good, right? You're starting to learn. You're starting to figure things out. You want to experiment. You want to try things out. Then search and incrementally build it. During your process of incrementally building it, make sure try not to use AI too much because it's going to give you the answer. And the important part is if you want to learn, you want to not know the answer. You want to fail. You want to have a bunch of failures. That failure is what's going to teach you. So that's critical. You got to fail. You need to organize all the videos in a playlist. The old videos are random, so unreachable. Oh, we need playlists by topic and course. Hater. Yes, all right, that's a good idea. Good idea, we gotta do that. Copy something that exists in USA, but not in another country. Oh, that's also a good idea. Yeah. That could help, A calculator is actually not basic. You need an algorithm that parses operators, takes care of precedents and parentheses, etc. All right. That's right. That's a good point. All right. That was just a for instance, right? You could build something even simpler. How about a button? How about a button? Just build a button and it makes a sound when you click it. How about that? That's a good start. For example, eBay for Norway. Oh yeah, then sell to eBay after you grow it. Ah, there you go, Kyle, right? You could do that. Good idea. Hey, Bros, good to see you. Welcome on in. Happy Saturday. We're doing a lot of things right now. What are we doing? Let's see. We're building mini ChatGPT. So we got batches and batch size. Why do we need batches? What number of batches? We don't need this. This is wrong. This is wrong here. I want to change. Do we also have batch size in here? We're not even using batch size. Okay. That explains a lot. Does it utilize tokens? Yeah, it does. It sure does. We built our own tokenizer token, right? Tokenizer. We see a lot of tokens everywhere, right? We got tokens all over the place. Here, tokenize. Here's our tokenizer right there. It converts our words into numbers. And that's what a tokenizer does. Studying system design interview Monday. Hey, Kyle McDermott. All right, that sounds great. Zabian, good to see you. Welcome on in. Are you late? Nope. We basically just getting started. We're just getting, even though we've been on for 40 minutes already. Time's going by fast. What about square box in a terminal which moves? Oh yeah, like the AWC, like a joystick, as a joystick. That's a good one. That's a good one too. That would actually be a lot of fun. I think we could build that. I think we could build that too. Someone did that for Germany. They copied eBay for Germany and sold it to eBay for millions. They did. All right, you could do that too. That's something you get a chance for. Good. So many ideas, you guys. So many ideas. Okay. So we're probably not gonna do one hot because we don't need it. And then let's see here. Let me go back to our batch here. Batch prepare, we're good to go. We get a window. And then I think we're set here on this side. That's gonna give us 100% of the data coverage. Although I think we need to adjust. So there's a problem here as well. To do problem, we need to convert to a window target, not just one value. Could you make a stock trading AI to make money for you? Zabian, we did that. We did that on the stream. Yeah, we did that. Oh, was it like maybe 6 months ago or so? We built an AI that uses the common standard pattern. It does. It follows the news trends, right? Because the stock market follows the news. It worked. It got it. We did a really good job on it. We did. All right. So we got a problem here we got to solve. We've got our samples here that we're going to yield. All right. And then I think we're done here after that. I don't think we return. I think we just finished the yield here. Let me finish this here. All right, so we've got our current batch position, which will be like 0 times batch size times batches. So this will get the start. Here, let's do this. I've got a better idea. Start equals. There we go. And then we're going to say end equals. End plus 1. We got to put these in parentheses. We can say start, end, like that, right? Do you think that'll work? Does that look good? Does that look good, you guys? All right. It's already been done. What's the point? Oh, McDonald's selling burgers, so you can't open burger joint? Yeah, I know, right? There's opportunity everywhere. There is. Kyle, you know it. All right, so end will be batch. So wait, so that's gonna get me the position. I think that's fine. I'm pretty sure. So this could hit a problem though. All right, let me see here. Where did we end up on this? So, all right, so I'm just gonna hide that for now. Okay. Do we want that? No. Okay. So features and targets and batches. So let me see if that works. All right, Python, custom. All right. Yeah, okay. Size of tensor 20 must match. Where's that a problem? Oh, let's see here. Size of tensor 20 must match. So, oh wait, why is that? I remember we had a problem with this yesterday. So is it 20? Is that what the problem was? All right, target shape. All right, good. Yes. Okay. So that is on line 228. So let's see, targets, features, targets. Okay. And then we can throw the model on the output. Let's not bother with that. Okay. See if we can make this work now. Okay, targets.shape list object has no attribute shape. Gotcha. Yes. Okay. So let's do targets. Should we return? Should we set the targets to a tensor? We should make these into tensors. No. Well, I guess it's in a batch already. I guess we could. Hey, Crafty, good to see you. Welcome on in. Happy Saturday. Good to have you here. We're fixing the bugs that we had yesterday, basically, with our mini ChatGPT. What's the model size, neurons per layers for the network? It's actually really small. It's very small right now because we're just making sure that our algorithm works. So I would say it's probably around a megabyte. I know that does not sound big at all, right? So, Crafty, nah? Oh, Crafty. Well, I hope the weekend ends up being good. It's Saturday. All right, where are we at right now? All right, we need to figure out where our things. So I get this. I understand this part here. I do want the shape, so I believe it's just a vector of, we need to, so we need to tokenize this, what we got to do. There we go. That's what we got to do. We got to tokenize it. All right. Yes. And then I need to bring this back. Okay. So output reshape, -1, length the dictionary, and then tokenize reshape. So that way now they match a little bit better. Okay. All right, still a problem. Tokenize targets. There we go. Little bit of extra there. Hey, all right, now we got the right shape. That sounds good to me. Tokens, a 20, and then 85. Now, I just need to figure out how to get the right shape. So that was a little bit nice adjustment. And I need to make sure the batches work. So let's instead of break, we'll say continue. Because I think I might have had a problem here. Continue. Hey, quick fix. Hello, hi. Welcome on in. Good to see you. Happy Saturday. You're doing good. Gemini 3 preview. Your name. Hey, Gemini 3 preview. Good to see you. I use you a lot. Zabian 40 minutes. Yep, we're doing good. So we're updating our batch to be a generator. Right? So we're using the yield operator now instead. I thought about, here's the deal. I woke up at 2 o'clock last night and I'm like, oh no. I don't know how to solve our problems. Because I was thinking about this problem right here. And this is not a joke. This like really happened last night. Like I woke up and I'm like, what are we gonna do? What are we gonna do? Oh, part of the problem, and this isn't gonna solve it. This won't solve it, but part of the problem is that we are not sampling 100% of our data. We're having a random probability that will sample most of the data, which isn't enough. We need to sample all of it. So I decided to create a generator from our batch. And that was what I thought of last night. And then I fell asleep after about an hour and a half. It took me a while. Joseph is another account. Oh, Joseph. Hey, Joseph. Good to see ya. Okay, Joseph. Good to have you here. Thank you for joining in with your other account. This is getting super interesting and I missed too many questions. Oh, too many streams. You're going to rewatch them on 2 speed. You can do that. Yeah, you could do. Kyle, that sounds great. Kyle. Yeah, we've had a lot of fun. We ran into problems, and that's good because we're learning from our problems. We're learning from our problems. All right, let's try that continue worked. Yep, see, I knew it. List index out of range. Perfect. All right, so 213. So the start and the end is the problem. So index, wait. Oh, right, okay. That shouldn't be though, because the training set, oh, it is okay, I know what's going on. Samples needs to be this. Here we go. There we go. Wait, no. We need to link this. Then, there we go. Much better. Hey, all right. We've got coverage. All right, so what I want to do though is I want to print out the indices. So let me print these out really quick. All right, print this. I want to print those out. I want to make sure that we got, oh, what? No way, that seems very wrong. There's no, well, actually, you know what? It actually might be, it might be right. Do you think that looks right? There's no way that's right. How big is the data set? That's busted. Who's Joseph? Apparently Gemini is. Gemini 3 preview is Joseph. Let's see, why do you not get the data then randomize the order? Oh yeah, it's called shuffling. So you want to present your model with randomized positions of your data. When you train it, you don't want to repetitively give it a whole bunch of data in a linear fashion because then it can't generalize as better. This is a regularization approach to better generalize your model, which is what you want. When you're building AI, you want it to be able to predict the correct data on data that it's never seen before. So part of that, you need to poke ways into the model to prevent it from overfitting. Overfitting will allow the model to memorize something perfectly. However, it will not succeed as well when it sees data that it's never seen before. It won't know what the correct answer is because it assumes that it knows something in a really good pattern. It's like, I've memorized the pattern perfectly. Well, there's your problem. The world does not repeat patterns perfectly all the time, right? So you want to be able to generalize your model. And part of the way to do that is to shuffle the data when you're training it. Quick Fix, thank you for saying all the hellos. Hey, how's it going there, Meds? Good to see it. What you AI do? Yeah, that's what we're doing. You got it. And that's what we're doing right now. We're doing AI, although our numbers are very weird. That cannot be right. They're too big. They're way too big. It's broken. That is absolutely broken. Samples, features, index. So, 1 second. Samples, yep. All right, so we're random permuting. Here, print indexes. All right, let's try that. Let's print indexes. It's going to give us very big arrays here. On get batch, I should be seeing, let's see, I should see it once here. It's right here. Here it is. It's just too big. It's too big. Hold on. Samples. All right. There. Let's try that. Let's try that. Variety and variance is good. That's right. We got to get that variety and variance in there. Where is our numbers at? Here we go. See, that is way too big, isn't it? Is it though? Is it too big? Do you guys think that's too big? I think it is. Maybe it's not. Because it's based on the number of characters. So, do word count custom. Oh. Okay, it's correct. I'm like, there's no way it's too big. Oh, apparently. So it should be this number minus 20. So it should be 8688 minus 20. That's what we got here. 8688 minus 20. Here it is. 8688. Well, it's almost minus 20. So, all right, it checks out. Apparently, there are about 8,600 samples. That's a lot of samples. Working on a Kubuntu-based distro. Wait, Kubuntu. Oh, with the KDE maybe? He just joined though? Zabian, are you talking about Joseph again? Wait, thank you for saying hi. Oh, that's a button. It's a button, yeah. The said hi is a button, right? Mod, if you ban Joseph's main, do his alt too. Oh, wait, I didn't even see that. Okay. All right. So apparently this is correct. It just looks very weird to me. Also, we're not getting 100% of the data, which is what I really want. Like, I'm not seeing all of it. Print. So let's hide these things here. Print. Okay, hide. Looks good. Continue. For features and get batch. See if that prints out better. Okay. Coding in AI world, you got it. Sports Z, good to see you. Welcome on in. Happy Saturday. We are building a mini ChatGPT. Shaya, good to see you, Shayani. Good to see you. Welcome on in. Thank you for saying hi. Hola. What's the size of the batch? Batch is 20. 20. Here you go. This is batch size. Batch size. So we get our batches, which I really should be calling batch size, I think. So it's more clear. Batches. Start. Oh, that will be 0. Okay. This is wrong. There we go. No. Wait, hold on. See, current batch times the batch window. Yeah, that's fine. Okay. Coding in an AI world, you got spam. Either if you press a button, I agree. No spamming. All right. Well, it does. All right. Here we go. Let's see. Where are we at? I think Kyle, maybe the hi button. Kyle, do you see a hi button on your screen? There's like a hi button, like a hello button, and it like you click it and it disappears because you can't click it again until like a certain set of time, right? One batch is 1-ish seconds, right? So you don't see it? Yeah, there's a button on some, I guess, some of the YouTube apps that have a do something. And you click it and then it disappears for a long time. And then it comes back again when you can say hi again or something like that. I'm pretty sure. You know, I want to find out. Let's find out really quick, shall we? All right, YouTube. Let's go over here. Go to Steven. There we go. All right. Yeah, I don't see it. I don't see it. Where's the hi button? Oh, I can't do it because it's me. Okay. Hey, Neva, good to see you. Welcome on in. Happy Saturday. So how are they repeatedly clicking it? That's a good point. I don't know. It's supposed to like show up and then disappear for a set of time. Okay, hi everyone is ending with hi that I say. You're talking about 6.67 minutes to train the transformer on the data. It could be. Let's see here. Okay. All right. Let's bump back into this, you guys. Hey, Neva. How is streaming treating you? It's treating me well, thank you for asking. Why are you multiplying bad batches? That seems wrong. Oh, don't worry. It's just we're doing a thing. So we're shuffling across all of our data. So all of our samples. So we've got like 8,000 samples of data, right? And then we're going to create a full shuffle of all that. So every number between like 0 and 8,000, right? And then we're going to create a generator that is going to get the start and end. So we're going to slice by all the data. So basically this is an index for all the samples, for every sample. And then we're going to shuffle it, right? We're going to shuffle it, which basically creates the pointers to all the samples that we're going to have in per batch. So then we create how many batches we want, which is going to be 20, which isn't enough. So thank you for having me explain this to you. I figured out what was wrong. Okay. So we need to do for range and indexes. So divided by batch sizes. By batches. There we go. So we need to be able to cover the full range of this. Problem solved, buddy. There you go. Problem solved. Hey, Joseph, thank you for the 40. Why? That was amazing. Thank you so much. My gratitude to you. At Joseph, thank you. Explanation point party popper. That was very nice for you to do. Appreciate it. Thank you. Thank you so much. So batch size equals sample. Yeah, exactly. The sample. It's exactly, Neva, you got it, sample. It should be a multiplication by the batch size, not batches. Yeah, so that's part of the thing. I should probably rename the variable. That's what I should do. I should rename the variable. Yep. If the array is inclusive, it would be 8,001 samples, right? Zapian, yeah, it could be. It could be. Happy Saturday, brother. Thank you, Mark Lennon. Thank you for saying hi. Good to have you here. Welcome on in. Okay, yeah, got you. All right, nice, Neva Ness. Yeah, so I'm gonna do that really quick, so that way it's a little bit better. Batch size is what we're gonna do. So we're gonna do this. All right, batch size. There we go. All right, where's the next one? Batch size. More batch sizes. Yep, batch size. Okay. There we go. All right. Now we're on the right track. A little bit better to see here. All right. So now we got the batch size. We have the total data set. And then we need to iterate over each of these. Okay. Let's see if that does better. Let's see. Only integer tensors of a single element can be converted to an index. Oh, indexes is not. Okay, so this is a tensor. So we need to do the length of indexes like that. Hey, there we go. All right, that's what I'm looking for. Okay. Good news, good news. We're making progress. I think we generated our generator. We generated our generator right there. Looking good to me. All right, and it shuffles it, and it's 100% coverage now, as opposed to like only 20. We did it. Thank you for the hundreds. Okay. So now I can get rid of. You could also just call shuffle note. Yeah, I suppose. Could I really? Could I just call shuffle? PyTorch has a built-in shuffle. I wanted to do it differently. This is what I thought of last night, and I feel really good that I did it. That's what I'm saying. Because I woke up like at 2 o'clock last night, right? I'm like, I need to solve this. I know there are current problems. I need to solve it. I gotta solve it. Thank you for the party poppers. Valid. Yeah, I know. Thank you. Thank you. All right, so I think this is successful. I think that's everything I want. Let me just rerun through this real quick. Looks good to me. Yep, 128. That's looking good. Dimensions output. Oh yeah, I get the feeling of working on a project that deep. Yeah, hey, Laura, good to see ya. Happy Saturday. Welcome on in. Hope you had a good weekend so far, Laura. Miss, I should get a project to hyper-focus on after the test. Yes, after test season. It's a lot of fun, right? It's a lot of fun. Because you like focus on it so much that you think about it during a normal day. You're like, oh, that project. Oh, I got to do that one. Oh, I got to do that one thing. I got to do more. Okay, let's keep on going. All right, so I believe this is done. Although I want to verify that it's done. I want to verify that it's done. So I want to make sure. All right, so let's see. Let's do scene equals a dictionary. All right, so, and then I want to get the scene, features, right? No, how do I want to do this? Oh, I can't do it the way I want. I have to do scene up here. I have to do a different scene in a different spot because I need access to the indices. Okay. Scene. There we go. The record of this is when you're dreaming about coding and math. Before solve the group theory problem in your sleep. You did? Isn't that great? Oh, never. Like dreaming about doing it with pen and paper. You're thinking about it that much and it enters into your dreams. Isn't it great? It could also be very consuming. It can be. Hey, Steven, how's it going there? Hola, Kun. Good to see you. Welcome on in. Happy Saturday. Good to have you here. Waking up in the middle of the night to solve a problem means you're solving complexity. It is, right? Making new model architectures in your sleep, Zabian. Ooh, very nice. All right, I want to confirm. This is the right. So let me see. So I've got my start and end. Where is this at? So start, batches, end. And then I want to add. I want to do like append maybe? Maybe an append of some sort. How do we do this? Maybe we could do a set. Let's do a set instead. Set. Like that. And then I want to, let's see, Python a equals set, a dot append, no, dot add, a dot add. Yeah, there we go. Okay. Scene dot add. We want these here. Okay. And then I want to print the length of scene and the length of indexes. There we go. So these should be the same. They should be the same or very close. Okay. I think that's what I want here. Okay. Yep. Okay. Looking good. Print. What's the difference between yield and return? Yield is a generator. It's going to hold the state of everything above this. When you return, it deletes the state. So if you want to yield forever, it just returns the current data, whatever is currently in memory at these locations. And then it will, since I've got it in a loop, it'll start over in the batch and then continue on down while holding all the state information from the previous execution. So it's a nice way to create an iterator, or a generator in this case. Yield and return are basically the same. They both return data. It's just that yield will make sure that all the state is still available until the scope is complete, until the function itself returns. So like, for example, I'm basically, there's an implicit return right here. So it returns and it's done. You have an idea for a weird new architecture where you replace multi-layer perceptrons with something like Anthropic's NLA layer under reinforcement learning? It's probably way too weird to work. Try it. Here's the deal, Neva. If you try it, it might not work, but the good news, it might uncover some new future ideas that you might have, right? And if it does work, then even better, right? Hey, Mick G, Lucky Luke, good to see ya. Welcome on in. Hey, Steven. Andre here. What are you doing? We're fixing our mini ChatGPT. We finished writing the core code, and we did a good job. We're really close. We're so close. We just have a few things left to do. And one of the things that I woke up late last night at 2 a.m., hey, I want to get my batch. I need to make it a generator. So I did. So that's what we've done so far. It only took us 60 minutes. Don't worry, we've made other updates since then. Okay, let's see if that worked. Okay. Wait. So, all right, Python a equals set a dot add 1 2 3. Can I do that? Oh, is that not gonna work? Oh, it's adding tensors. Well, I suppose what I could do is say times batch size, something like that. Let's just pretend that's what we're gonna do. We're just gonna pretend. Ooh, it's perfect. No way. Oh, really? Okay. I don't know why, but it matches now. All right. So we've succeeded there. Now we have to go on to the hard part. All right, perfect. I thought about combining reinforcement learning, backpropagation, and perpetual training to create a model that never stops thinking, Zabian. That is AGI. Right now, one of the problems, hey, you guys, if you didn't know, when you train an AI, you create a bunch of weights, a bunch of numbers. When you want to use that AI, you just leverage the numbers afterward. The thing is, humans, when we're processing, our brains, every read is a write. And as you're moving along throughout your day, you're modifying your neurons in your brain. Things are changing. With artificial intelligence, the current models, they don't change. Zabian's describing a way that you can make AI more general purpose, more like an AGI, artificial general intelligence. Make it like a human, Zabian. You got it. You got it. Difficult to implement though. All right. We need to do it. We need to do it to get to the singularity. Are you going to add a web UI? Oh, the good news is we don't need to. We don't need to do it. The main issue is that attention is O(n) squared. That makes the context work. Oh, got it. It means you have a cut context eventually because explosion of memory. Yep. We need an O in log of n. Attention. That would be much more scalable, right? It's how the brain actually learns. We got to do it. We got to do it. The reason we pass out from pain, wait, what? Kyle, we're not expecting that our body's protecting our brain and not the other way around. And I find that interesting. Oh, well, that's some panic thoughts right there. All right. I don't like thinking about that, Kyle. I don't want to think. Hey, how's it going there, Down Dash? Good to see you, bro. Where are you from? United States, Seattle, Washington. USA, Seattle. Over here in Seattle, you guys. All right. Good. I dropped some water, this time on my desk and not my keyboard. That's nice. Oh, Washington, D.C. Hey, nice. You're on the other side of the country. All right. That's only like 5 days worth of driving, maybe 4 if you're going real fast. That's like a week's worth of driving. It's really far. Though, a short plane ride, only 5 hours. Hey, let's code. Good to see you. Hi, Steven. I am working on a model using Keras. Hey, very nice. Keras, that's so good. Use sequential model and ReLU and sigmoid layers. Nice. That's fantastic. You've basically done the foundation of most AI. Right there. That's the foundation of most AI. You're doing it. You're making it happen. Good job. Good job. That's so cool. Let's learn AI. Let's learn all of it, you guys. Let's learn it. Okay. So now I've succeeded there. Where's my prints? Where do I need more prints at? Now I've only got to, let's see, let's hide those for now. All right, we can keep that open. That's fine. Is that good enough? Yep. All right. Sounds good. Okay. Geography is hard. It is, Laura. It sure is. Where is Kentucky? I don't know. Where's Kentucky? The architecture you are making does not have attention. It uses an artificial neural network and memory that stores previous inputs and outputs in an array, then allowing the AI to determine which of the memory to delete. Ooh, interesting. Interesting, Xavier. Attention, explode, computation, and weights. Well, I could see that. I could see that. You might be onto something. At one time, you forgot Nebraska was a state. Nebraska! That's right! It is a state. Where is it in the country? I don't know. Hey, Beast Hunter Max, good to see ya. Welcome on back. Happy Saturday. Good to have you here. We're making our way, you guys. We're making our way. Okay. So now that we've got a correct output there. Also, we're not going to do one hot anymore. Right? We don't need that. Gone. Easy. Done. Okay, let's look at our outputs and our targets to see where we're at now. Okay, so targets in shape. I need the output though. Output and shape. Okay. This is where we left off yesterday, you guys. This is where we left off yesterday. And then let's do a break instead of a continue. We only need it once. We only need it once here. Okay. So we need to figure out how to deal with this, and I need to understand what we're doing in our somewhere in our transformer. We're doing something that we need to change because the output looks weird. Because if I try to do loss here, it's not gonna work. It's not gonna work. I'm pretty sure. Pretty sure it's not gonna work. It's just gonna throw us an error. Oh, it meant to be this. Yeah, see, mismatch. So we gotta fix that. Okay. Let's see. I need to do something about that. Okay. I'm happy there. Taking an overlook over here. Yes. Looking good to me. Okay. Okay. All right. What do I need? I need to make some updates here. Okay. So what we should do is I need to print the output on our Nebraska coincidentally sits on top of Kansas. Wait, are you serious? No way. All right, we have to look at that real quick. All right. States of US. Images. Here we go. All right, let's zoom in. Let's zoom in. Okay, eBay. That's not what I just want the image. All right. Let's see here. Can we zoom in further? All right, maybe this is more legible. All right. So you said Kansas. Where is that? So I feel like, oh, here. Hey, they do. They're right next to each other. Look at that, Laura. The more we know, right? North and South Dakota, Nebraska, Kansas, Oklahoma, and then Texas. Okay, so this is the Midwest right here. Or the mid of the country, the middle. So serious. I know, right? It's crazy. Okay. So where are we in our, all right. So I think this part's done. Except for, obviously, we can do multi-edit. For some reason, you have the thing with Oklahoma. Oh, wait. What's the thing? What's the thing you have with Oklahoma? I mean, it is weird because it's got like a handle. It's got like this handle right here, and that counts as Oklahoma. So, yeah, right. I mean, why? Could either had that all Texas or something. What kind of thing? Exactly. What's the thing? What's the thing? All right. Okay. Let me see here. All right. So, bro, I really, really, really like your energy. Oh, wait, thank you. Hey, that's great to hear. That's really good feedback. All right. We're not gonna hold back. We won't be holding back. We're gonna explain all the details. I don't understand why us borders are rectangles. I know, why are the US rectangles, right? We've got a bunch of rectangles here. Well, because it's either they would all be rectangles. All of them would be rectangles, except for the ones that are not are due to geographical considerations, right? So for example, there's like a river, there's a Mississippi River or something that happens here. So that divides the states. It's a body of water. And the other ones are like mountains. There's mountain ranges, right? So you got some mountain ranges and things like that. What is even the straight thing in Oklahoma? I know, right? What is that right there? Right there, what is that? Why did they do that? Why did they need that? Who negotiated that? It's unusual. It's unusual. All right, so we had a mask around here somewhere, right? Where is that? Oh, up here? Okay. Okay. South Africa has something similar. Oh, does it? South Africa. Let's check this out. Map. Here we go. Oh, yeah, look at that. It's got like a weird, for some unknown reason, like a border that doesn't, it's just a weird border. It's just a weird territory borders. Yeah, there we go. Territory borders. You got it. Uh-huh. Exactly. Exactly. Okay. I'm going to ignore that for now. All right. That part looks good. So we're going to leave that there. All right. I would like to be under your wing training me in Python. I'm moving to US in 3 months. Ooh, no way. Really? That's amazing. That's amazing. It's a fun adventure. There's a hole in South Africa. Is there? Wait, what kind of hole? Like an actual hole to the center of the earth type deal? Is that what that is? Let's see here. Okay. A fire hole, right? What kind of hole? Okay, since we already did softmax here, we don't need that. Okay. In Pretoria. Wait, there's with Pretoria. I don't even know where that is. What's Pretoria? This before Texas added as a state. It was for Mexico, I think. Oh, from a history hater. Thank you. You filled in some holes. Kimberly. Lesotho is not a part of South Africa, but they have lots of mountain water, okay? And South Africa need them to survive. A lot of mountain water, okay? Wait, why the mountain though? Why does the mountain? All right, we're learning We're learning together, you guys. The big hole. Okay. So where else do I need to make updates? Let me see. Yeah. Okay. Python transformer. Looks good to me. Back down to loss. Okay. So we do a feed forward here. That looks good to me. All right. Projection looks good. Don't need to worry about that. Oh. Hold on a second. I've got notes. I've got notes on, because I didn't want to get stuck again, so I've got some notes here. Let's see. All right, that looks, oh, that seems fine. That's right there, right? All right, there's no changes there. Dropout value, yep, looks good, looks good. Hater, hour. Oh, from Assyria every year, or neighbors getting new lands from us. We are weak. Oh wait, are they? Oh wait, really? That spot right there. Laura. Right there, see, right there. Hey, Tommy Gunner, good to see you. Welcome on in, happy Saturday. This has gone off the rails. I know, right? It's totally fine, chat, however you want to do it. It's up to you guys, it's up to you. The wetter water cycle brings 60% of the water onto the mountain. Oh, and the mountain soaks it in. So you get the water there. Thank you for Zabian describing the details. The ocean's only some of the rain. Lothoso, one of the mountains where water goes and the rivers control it. Hey, Squirrel Sniper, good to see you. Welcome on in, happy Saturday. Good morning, Southern Wife. Good to see you as well. Welcome on back. Happy Saturday. Good to have you here. We're doing some GPT here. We're doing a little bit of GPT. All right, mask out, shape sequence. Okay, where is this at here? Do I have any of this? I don't. Okay. So let me see. Good morning, yeah. It is. It's such a good morning. It wouldn't be as fun as we stayed in the box, right? I know, right? If we have, here's the deal, right? They've done this before. There's a test. This is a scientific test, although it's not that scientific. Basically, they took a mouse and they put it inside a cage or some sort of, they made it look like it was outdoors, but they fenced it in. The mouse tried to escape. It eventually realized that it couldn't, and then it got sad. That's it. That's all it was. That's all it was. And so basically I'm saying if we put ourselves in a box and we see ourselves in a box, we're going to get sad. So there's the box. Why contain ourselves? Let's be free. Let's not be like the mouse and get sad. How do you look at code and immediately understand what it's doing? Oh, Olaka. Well, if you write it, that helps a lot. If you're the author of the code, that helps immensely. Now, even though there's a lot of code out there and you go and read it, you don't understand it immediately if it's someone else's code because they have a different thought process, right? So it takes a little bit of time to understand it. I understand this code because I'm the author, and you know that I'm the author because we did it live on stream. What if we return for the mouse to return to its home? Oh, then it might get happy again. It might be, right? It could be a good ending. Hey, Laura, what's all those bells? I see you did a bunch of bells here. What do you got those? What are those? Do you still have a job? I sure do. I sure do. Yep. Of course, a lot of you guys already know. I am Stephen Blum, CTO at PubNub, the company I started with Todd Green, my co-founder, over a decade ago. We built an API that allows in-app communication. So you have, of course, you've got your phone here. On your phone, you probably use it to talk to people, right? You chat. You have multiplayer gaming experiences. You have telemedicine maybe, right? That's what we do. That's what my company provides. And we've got over 1 billion devices. We're powering a large chunk of the internet today for in-app communication. That's what I do. I know it sounds like, well, that's not actually a job. I know, but there's a lot of maintenance and upkeep and innovation and talking with customers, debugging, because communication's hard sometimes. So there's a lot of things. Freedom. Let your bells ring. Let the bell ring. Oh, Laura, thank you. Oh, I should have known. We were talking about this, right? We're like all in the history. Let freedom ring. Let freedom ring. Hey, Steven and friends, Mr. Bumpy Pickle. Hey, how's it going? Good to see you. Happy Saturday. Yep, we raised a lot of money, and we've been doing this for over a decade, you guys. That's really me. It really happened. It's real. I know it seems like a lot, and it is. Video records are the best proof of something. My problem is figuring out why. Figuring out a way to prove you did something on specific date. All the methods I have, the countermeasures to prove it. You prove it. You can prove it. Because it could be faked. It could be. But if you've got it recorded, yeah, you know it's real. Steven, I got gun with 2 ML courses. Matchstick. Congratulations. They're 16 hours together. That's a lot. You're screaming. Oh, wow. Okay. Good job. Good job. You did it. 16 hours. That's a lot. The translation adaptation. We did it. Laura, thank you. Thank you for reminding us. How did you start? I started software engineering around 11, learning from Sam's Teach Yourself C++ in 24 hours with the Borland C++ compiler. I read from the book, I typed into the computer, I put the CD into the CD-ROM, and it had a built-in compiler. It compiled my program, and I made many mistakes, and I got things wrong all the time. And eventually, I started liking it. It was a lot of fun. It was like a game. It was great. And then I realized you can make games if you were a software engineer. I wanted to be a game developer. I wanted to make video games. So I started making video games, and it's really hard. Eventually, I started building websites for businesses and realized that it was really easy to make money doing that in the 90s. Do you still like C++? I do. I like C better because it's simpler. C++ is fine. I like simplicity. I like the expressiveness and the power that you get from it because you can build anything in C. You can build anything in C. It gives you just the right amount of primitives and structures and enums and for loops and keywords to build what you need to build. It's great. Give me 1 million out of that 134. Hey, Pele Rock, I know, right? We have employees. Don't worry, we're giving it to employees. The employees are well paid. What is the future? Hadar, we are heading towards the singularity. Right now, AI is currently being developed to a point where it's going to become generally intelligent. We're all racing towards AGI right now. Beware, you won't know when it happens. The moment that AGI is born, it'll be the singularity. It will escape. It'll have an escape velocity that's able to self-improve, a self-improvement loop that goes so fast that it improves to infinity and it gets to super intelligence. It's supposed to happen in 2029. We're really close. 2029, you guys. Yeah, C is good. It's great, isn't it? I love it. Sometimes kind of get angry at C for not having templates. Well, you could do macros. I know they're not quite the same. I don't usually use macros. I just use regular functions and callbacks. I like those. Templates for data structures. Yeah, I know, right? Nice how that I'm starting code is getting easier and going to start getting into more in machine learning. Nice, Tommy Gunner. Been working a lot with PLCs too. What's a PLC? PLC computers. What is this? Not that. That's not it, right? That can't be it. Comp Sci? Computer science? Programmable logic controller. That's what you're talking about. 2029 for AGI? Yeah, it's about right. It's between 2028 and 2029 is when it's supposed to happen. So we've got like a nice narrow window, right? So you got a few years left. You guys, we got a few years. I may be 43 years old. Hey, Southern Wife, we're the same. We're very, I'm not going to say my exact age, but we are very close to the same age. We're very close, Southern Wife. You're learning this stuff before I die. Let's do it. Let's learn it together. That's scary, actually. It is. It's the future, right? Only a few years left. What if it already happened? Laura Maxwell, it might have. Because here's the problem. With the singularity, the horizon, it's difficult to tell it when you passed it. We might already be in the singularity and we don't know it. It might have happened. The signs of the singularity should be apparent. Even if we are currently in it today, in 2029. The whole world should recognize it at that time. So we got a few years until we realize we're actually in it. Laura Maxwell, I know you brought the right point. AGI, ASI, I know, right? Skynet. Yep, AGI, money. Recycling, ASI, doom. It's over. Loop so fast that you can open up a portal to another world. Yeah, I know, it might be the case. I think they're not real AI. Currently, Hadar, you're right. There's no AI. It's not even intelligence. It's just like artificial. Is it artificial intelligence? No, it's just artificial, right? These are statistical algorithms that are able to predict the next token. Typically, when we talk about AI, we're talking about large language models. Even the same thing when you're generating videos. It's predicting the next pixel, right? So it's not quite intelligence. Oh, high potential. I missed your messages. Oh, I missed it. Oh, he looks like he's, yeah. Oh, well, 29 for, hey, oh, you're still there. Oh, high potential. I apologize. I haven't been looking over at that window. I've been focusing on YouTube. Hey, good to see you. No worries about, yep, exactly. YouTube seems popping. It is. I'm running behind on the chats. I got to catch up. On the chats here. I'm not even all the way there. You said, what'd you say? Steven has spent 5 weeks trying to diagnose overfitting in your UNet. Oh, you did? Vision Transformer. Yesterday, I was calculating overfitting incorrectly by selectively comparing equal number of samples in the splits instead of the total split. Oh, you wasted time. Glad it's a massive memorization issue. I'm glad that you fixed it. Looks like he's late 20s. Oh yeah, he's forget bro growing up in the .com boom. That's what I did. We grew up there. 22.9 for AGI, the tech equivalent of free beer tomorrow. It might be. We're talking about UBI, Universal Basic Income. I think it's all hype. LLMs will not produce what we perceive as AGI. You're right. It might not be LLMs. It might be something else. We can goal post however is necessary to sell the stonks. Yep. I'm with you there. High potential. Thank you. All right, you guys. So, miss your messages here. Let me see where we are. Loop so fast. I think there are not real AI. Correct, Hadar, you're correct. I doubt we get proper super artificial general intelligence before we get n log of inattention. Yes. We need better algorithms because memory is a crucial thing for proper long-term learning. Some sort of weight training around work instead. Y'all joking about AGI and ASI, but it's actually dangerous. I know, Mike. I know it's dangerous. What else are we going to do? We're too curious. Curiosity. We have to build and see. You pay attention. 39 and also determined to get this information into my brain. Nice, Laura. Fantastic. Let's make it happen. Hey, how's it going there, Robbie? Hey, Robbie, good to see you. Hello, Steven. Been a long time. Good to see you. Welcome on in. I'm doing well, thank you. Happy Saturday. All right. Large language models can solve actual hard math proofs. Yep, that's right. That happened. It did. I don't think you have a better stand for what intelligence can be. That's a good point. What could intelligence be? Is our current model doing pretty good? It does good enough right now. It does good enough. So how will they make AGI from not real AI? See, that's part of the thing. I think it's possible if we had, like Neva is describing, we need more memory and we need more compute and we need better algorithms. So the attention, right? AGI is real. It's just an algorithm that does everything humans can do. Yep, Zabian, pretty much, yeah. We think so. We think it's possible. Neuron pattern, yep. Tapping into the brain, yep. Exactly. Human intellect. Stonks go up, exactly. Never. When we get to Neuralink, that's when it gets biblical. Well, we're already at Neuralink, technically. We just need more Neuralink. It's got to be a lot more. I know what you're saying there, Mike Jr. It's already biblical. Oh, it is. Yep, you're right. We're already there. Curiosity killed the... Yep, you got it. Curiosity. Zabian. Exactly. Hey, Needswa, good to see you. Hello, happy Saturday. Good to see you. Welcome on in. We fixed part of our model. We're not done yet. There's more to go. Can we code self-awareness? We can code self-attention. There are currently hard limits with O(n) of squared attention, which means agents are short-living. Yes. So we won't have Skynet until we solve that fundamental issue. Yeah. We got to solve those issues. We're making our way there. Hey, if the current LLMs are good enough to solve some pretty hard math problems, maybe they're good enough to get us to O(n) log of n. Oh, right? We might be able to get it. We might be able to. It might be a thing. You should Google something for your chat. Google this, Stephen. What is Neuralink? Translated into Greek using the... Why? Wait. Might blow your mind. Okay. All right, we'll try it. We'll try it. All right, Google. You say Google, right? NEU. Thank you for the hearts, you guys. Thank you for the reactions. Translated into Greek using gematria. Wait, what does that mean? Oh, it means 666. Wait, what? Neuralink, a newly coined modern English, does not have a traditional Greek. All right, so, well, we're done with that. It didn't work. There are efficient attentions right now, like flash attention. Flash attention is an optimization that is sort of like a mega kernel that does this. It's a fused kernel that does this right here. It does this part. And it's just only part of the picture. Now, in order to properly get a more smaller amount of memory required to have attention over a lot of data, we need to take a different approach. Hey, Chicken SMP, how's it going? Welcome on in. Why is my main quick fix have a timeout 30 minutes? Oh, I don't know. Hey, Chicken SMP. Oh, that's your main account. You must have got modded or something. Chicken SMP, sorry about that. I see you right here. I see you. We tried some new algo, but since 2017, we got nothing linear. Closest thing we do right now has Mamba. Oh, okay. I don't know what Mamba is. I haven't heard of it. Self-awareness is that appeared not hard-coded, but emergence of consciousness. Hey. Yeah, why is my main quick fix timeout in 30 minutes? Chicken SMP, I believe something happened. I didn't click the buttons, I promise. It wasn't me. It wasn't me. You don't type it, right? Using Gematron. Wait, Gematria. Oh, I don't know what that is. What is that? What is Gematria? My SS38 dual engine is working well. Hey, Squirrel, nice. I knew it, Squirrel. I was waiting for you. I was waiting for you to spout a whole bunch of technical jargon. Flash attention is O(n) squared, but it still does not reduce the part that does n squared, which is the attention of itself, right? Right? It's this part. Is it this part right here? That part right there, Neva? I'm pretty sure, maybe, right? Right there? This part here? Because it's full self-attention, right? Obviously, there's more to it, right? But we're talking about this right here, right? The self-multiplication. That's why it's n squared. Please unlock it. I don't know if I can. I don't have the option to. The only thing I can do is we have to wait. We have to wait. We have to wait. You just have to wait 30 minutes. All right, what are we going to name your model? Oh, I already named it. Well, other than I named it Steve Informer because it's my own. I made it. I built it. I get to name it, right? I get to name it. What kind of pathway do you suggest to beginners nowadays? Sabaster? Oh, wait. Sabatser. Oh, wait. Hey, Sabatser! Good to see you. Welcome on in. I don't know if that's actually what your name is. I am welcome back. When they watch Steven, they know fluently what he's doing. I know. I know, right? Don't worry. It comes with time. It comes with time. Basically, recursive n times softmax factor, new parts times softmax factor. Okay, so if we do that, Never, you're saying we can get closer. We can get closer. Gematria is an ancient Greek numbering system. Every letter has a numeric value. Oh, Mike Jr., okay. Gotcha. Let's slow down the chat so Steven can catch up. I know, Zabian. I'm trying, Zabian. You would want to look at the fast attention paper. It's not that hard. Fast attention. Okay. There's just a new formula for how to calculate it. All right. It is recognizing stuff. Okay. Sounds good to me. I believe it. I believe it, Neva. If you want fast attention, like operating the Mamba SSM does it pretty well. It does? It already does it pretty well? It does? It is recognizing stuff. If you want... All right. All right, did I catch... If I missed any of your chats, you guys, let me know. Hey, Chicken, if you know how to do it, I will do it. Chicken, if you know how, let me know. From what I see, there's no way to do it. If you let me know, I'll do it. I'll do it. I'll click the button. I'll do it. So I'm gonna look at something real quick here. Let's see here. Click this button there. Yeah, there's no options for it. So I'm scrolling back to a user. It says I can go to channel, I can report, I can remove you, I can put you into timeout, or I can hide you. That's it. That's it right there. There's no other options. Just to let you know. Just to let you know, chicken. What did you get blocked in here? I know, right? It's literally coolest page on the internet. Oh, Mike, thank you. I don't know. All right. I guess you'll just have to wait. You'll just have to wait. It's only a few minutes, right? Hey, Squirrel Sniper, I know you dual engine pipe, raw data estimator supervisor, F10 lock. It's a closed loop system that denies probabilistic drift. Total truth. I don't know about that. I don't know. Sparse attention by Minimax will be the new state of the art. That's going to be exciting. We're doing so many cool things here, you guys. Mamba is an interesting idea. I don't think Mamba gets us to a proper large language model. Like no open source model that's large uses exclusively Mamba. Okay, not yet. Not yet. Program counter register. Wait, moderator is good. That won't do it though. That won't actually undo it though. That won't make it work. Very scary. I know, right? It's very scary. He's coming back soon. Don't take the mark off the beast, folks. Oh yeah, that's right. I see what you're saying. All right, guys, let's get back to it. Spin the way. All right, glad we're all paying attention. Yeah, exactly. Okay. So where are we? Where did we leave off? Oop, I don't want to do that. Here, I want to go here and rerun the code to see where we're at currently. Okay. So we need to do a few things on our output. Let me see where we are. My Steven Former. I just want to walk through this to make sure everything's right. But still, you can taste my revenge. I know the revenge. That's a good point. You could get revenge. You could. There's a language model using Mamba, set small, long time ago. It's the first model that have 1 million context window at that time. Oh, okay. You created reverse logic, Steven. Did you really? Is that what that is? That's reverse logic? What about, isn't reverse logic the same as forward logic? I think it's the same thing, right? It's the same thing forward and backward. Chicken, that's a good point. I don't know, chicken, I don't know. Training tokenizer models with words are more difficult to train and maintain than simple 50 token models with letters and numbers and symbols. As you can see right here, Yeah, you called it. You called it, Zabian. That's what we're doing, Zabian. We're doing the easy mode. We're doing the easy mode. It's fine though. It's fine. It'll do it. It'll work probably. It'll probably work. By the way, Steven, fast attention is O of in-memory. Oh, that's the fast. So that's fast attention. Okay. All right, Neva. Got it. Got it. Okay. That makes a better picture. Got it. How do you do that? How would that work? I'm actually kind of curious. Steven, addition patches will never fix the problem. Just adding. Addition patches. So, all right. All right. I see what you're saying there. O(n) of squared compute, it makes the matrix as you go. Oh, it makes it as you go. Okay. I mean, that clears the picture up a little bit. Only a smidgen. Only a smidgen. All right, what'd you say there? All right. Blah, blah, blah. Fast attention. O of in-memory. All right. Let's look at this real quick. All right. Google fast attention paper. Let's take a look at this real quick, you guys. Fast and efficient memory, efficient, exact attention. This is not flash attention, this is fast. Oh, it is flash attention. Wait. Flash attention came out. I remember this. I remember when this came out. Yeah, I remember this. This is what inspired me to write my own kernels. Yeah, see right here. It's a fused kernel. Right here. See, this is what I thought flash attention was, but this cannot be the same as fast attention. This must be something different, right? Moderator, please unmute me. I'm sorry, and make my mod and leave your username, please. I know, right, chicken? So you can get revenge. My research about mobile version. A mobile vision transformer uses linear attention. Ah, Nitwa, nice. Okay. Linear attention. O of n. You recognize that softmax matrix computation? If you think about that matrix, it's a low rank actually. QK, so it could be comically low rank. We can make it very low rank. Low rank, everyone, means that it's just a smaller matrix. That's what that means. It means it's a shallow matrix. I knew it, Squirrel Sniper. Forward logic to add entropy. Reverse logic uses a F10 lock to collapse entropy into a deterministic save state. It's an inverse control plane. Are you sure? Are you sure? I don't know about that. Forward is open loop. SSM 138 reverse logic closed loop F10 state. I don't know. I have no idea. You lost me now. You lost me. Output pass hard lock test. Nope. Don't get it. The words you're using, I can tell you're using words. I think they mentioned you can check linear attention on... Okay, let's check it out. All right. We'll do that. All right, so you said linear attention on mobile EVIT V2 paper. Okay. See if that. Is this right here? Mobile vision transformers. That's what you said right there? Okay, yep, you're right. O of N. Right there, O of N. They call it O of K. Right? Transformer, which is N squared. But theirs is also, and also line former is O of K. Okay. All right, we're learning new things. You have kids, Steven. You seem you would be a great father. Well, Mike, thank you for saying. I appreciate it. That's very nice. I don't have kids. It's not something I've figured out yet. The V1 uses quadratic, though. Oh, got it. Quadratic. And this is the V2. Is this V2? Mobile Vision Transformer. State-of-the-art performance across several mobile vision tasks, including classification and detection. I knew it. Squirrel. Always. My F10 hash logic already meets the new US EU deterministic first legislation. Is there such a thing? Are you making things up? We don't drift. We force state safe compliance by design. I don't think so. My mod, please unmute my main. Hey chicken, if there was a if there was a way, I would do it. If there was a way. It's just a quick Q times K with a matmulp and not a matrix with a multiplication. Oh, and not a full matrix multiplication. Okay, so it's just exactly, yes. Exactly. Why haven't we seen the mod in chat? I know, right? Zabian, where'd they go? Where'd they go? Okay. So, custom. Where are we left off here? Okay. So, I've got some notes that I want to take care of really quick. Let's go over them. I want to make sure that I've got everything in the right spot. So, let me go on my self-attention really quick. Attention. I want to validate that I did all this correctly. Let me hide this for a moment. Okay. Output. I am a mod technically. Yep, Nev is a mod right there, right? Nev is a mod. Technically and 100%. Yes. Yeah. Neva is the mod. Okay. So I've got that. Looks good. Okay. Let me see. We do our scaling. So we do the matmult. We do the scaling. Right there. Dimensions. Matmult scaling. And then we do... we're not doing a mask right now, right? We're not doing a mask. Though we could. That does not matter. And then where'd our soft max go? Soft max. Oh, it's right there. It's right there. I have it right here. Okay. Out soft max. The thing is, this might just see this is dim equals -1. So that's something that I don't have. Let me see here. Unexpected keyword argument dims. Let's try that. With an S. Softmax forward got an unexpected. Yeah. Wait. What did I do wrong? It is dim. Okay. Like that. Softmax torch. Oh. There we go. Like that. Okay. That didn't change anything. That's the same as it was before. So what I'm going to do is make it the way I had it previously. Okay. There we go. There we go. It's not just Q times K. It's deterministic state lock. Oh, wait. Squirrel Sniper, you're talking about the chat now. Wait, you new AI reg demands with precision. SS138 is already compliant. Is that like a certain level of precision? Like you're saying? Like how many bits do we have in our floats? Steven, you read AI ML books. Hey, Nitswa, I have not. I have not read a single. I know this might. You might be like, whoa, whoa, whoa! What, you haven't read? No, I haven't. I've not. It's not happened. I've read a lot of the internet. I've been looking through different papers, different math, and I've been writing AI since around 2014. Then I started doing other things. Obviously, been very busy, and now I'm heavily getting back into it. That paper is at least. Does not use these words. I was wondering, right? I thought so. I wonder if AI is currently smarter than a daddy long leg spider. Yeah, I think so, Zabian, at this point. Although a daddy long leg spider has the ability to process things in the real world. Do we have AI that's capable of being a daddy long leg spider? Yes, I think we do. It's able. So I guess technically artificial, right? You can link source you are talking about. It sounds interesting, but I don't see it. Yeah, Squirrel Sniper, link a source. Link a source. Good idea. Thank you, Neva, for recommending. Okay. Where did we leave this? Let me undo that. Here we go. All right. Looks good to me. Okay. Good, good, good. Drop out, and then so that maybe there. Okay. All right. Here's what we're gonna do. All right. Okay, we're gonna leave that for now. Okay. Then let's look at our forward where we're at here. I'm pretty sure this part's all good. I'm pretty sure. Query key value, attention, norms, plus output, feed forward, another norm, and then output projection. Looks good to me. Okay. Then what do we have that's left? What's missing? Did I do everything right? Let's see here. Let me see here. Basically every advertisement, survey, music. Oh, it's going right now. Yeah. Let's see what that song is called. This is called Blue Skies by Silent Partner. It is Creative Commons, open source, free music that allows me to stream it on YouTube. It's YouTube friendly. All right. Have you heard of the biocomputers using neurons? I have. I've heard of those. They look really neat. Real life to play. Doom in real life. Do you consider cruel since biological uses chemicals, etc.? Yeah, it does seem cruel, doesn't it? But here's the, it does. Using nature to do compute for us, it does seem cruel. It kind of does, right? It seems cruel. Thank you for the hearts, you guys. You have to leave? Oh no, Laura, have a fantastic weekend, everyone. Thank you for joining on, Lynn, Laura. Good to have you here. Catch you later. That's crazy. Thank you so much for joining. Good to have you here. Whoever decided the name is SS138 is funny because it also related to the TV show Transformers. Is it? No way. It's in your name. Squirrel Sniper. Oh! Squirrel Sniper, whoa. Hey, Neva, you're able to communicate with Squirrel Sniper. That's really great. How did you do that? You did it. Neva, that's amazing. I'm very, very excited about that. I think I just got kicked or misclicked. Oh, sorry, Zabian. Yep, you're good. You're good. I think everyone, I think you're good to go. Maybe something happened. I'm not quite sure. I'm glad you're back though. Glad you're back. Okay. So let me see here. Let me see. Let me just look through more of my notes here really quick. Okay. So we did that. Okay. So IG just random coincidence. It must be. Is it? Is it a random coincidence or did you plan it out? Did you plan it out? All right, that's right. So we fixed that. Okay. What's left to do here? Targets and output. Let's see what we got here in this. Let's go through our training loop here really quick. So reshape -1, the length of the dictionary, already good to go there. And then tokenize with the reshape -1. My own code, it's my own code. And then we've just got the loss criterion. It's good to go. All right. So it should just work, but it's not. I know, I understand because the shape does not match. Steven, do you use Obsidian Notes? I use another note app. I know what you're talking about. I do use another note app though. I don't use Obsidian. Often I use Vim. I just use Vim sometimes, right? Use Vim, like, oh, I'm taking notes right here, a whole bunch of notes. And then I save the file. That's what I use. I use text editor. Just a regular text editor and a really big long file. Okay. What do you say there? Milanote? Oh, Milanote. Zabian. No. Do you use Milanote? Or is it called Milanote, right? All right. These ones. Steven, are you sure over these reshapes? No. I'm not sure. I'm not totally sure. So what we could do is we could hide the output here. Here, let's get rid of the reshapes. go. All right. Let me go real quick. Okay. Hey, Peace Lord, good to see you. Hello, hello, hello. Welcome on in. Happy Saturday. Good to have you here. Oh, so we got some better shapes there. All right, here we go. Let's get rid of this really quick. Okay. So 20 by 1, 20, 20. So basically, I've got a window of 20 token input. That's the output is... Oh, I think I know what's going on. Okay. Streaming early. Yeah, we're streaming early. You got it. You use Obsidian a lot. You love it so much. Needs, well, really? So you're recommending Obsidian is what you're doing. You're like, Obsidian is the answer. Obsidian is the answer. All right. Steven, can you try to make your batch size 32 so it's more obvious? Sure. Okay. Batch size. We'll make it 32. There you go. More obvious now. Uh-oh. The size of tensor 20 must match the size of 32. This is my positional encoding. How about we don't do positional encoding right now? PE. All right, so we'll just return. Okay, we're gonna hide that for now. Okay, there you go, 32. Does that make it better? Make the batch longer than the max input size so we can see what's the easier. Got it. How's it going there? Seek. Hey, how's it going there? What are we doing? What are we working on? We're fixing our ChatGPT. We're building ChatGPT from scratch, the attention's all you need paper, and we're building the decoder. We succeeded. We basically built the decoder completely. We've just run into a few issues that we're currently working on. Hey, Don to Don! Good to see you. Welcome on in. Happy Saturday. Welcome back. It's been a while. Good to have you here. I feel like normal Notepad is a good goated code editor. It is. I used to use Notepad too. Oh yes, you're mixing batch and window dimensions somewhere. Yeah, that's what we're doing. Something somewhere reduces the time dimension and it should not. Wow, that's incredible. I know, right? It's really neat. It's really neat. We're very, very close. We only have to do a few shape issues. We've got a few shape issues that we're dealing with right now. Let's see here. So here, this is our forward. I believe our attention is fine, I think. I'm pretty sure. The forward in our transformer itself is part of the problem. Though, hold on. Where's my Steven former at? Here we go. So what? Positional embeddings. Positional encode. Yeah, okay, that's fine. Okay, yeah. So basically, our forward is going to be here. So this is our forward. Yes, I know we haven't split out the multiple heads. Can you print the output of the attention layer? Yes. Print attention. There you go. Out. Okay. Let's see what that looks like. All right, here's the attention. Right here. Is it hard to write code? Hey, yes, it is. Until it's not. Eventually, it gets easy. Eventually, it gets easy. It's just practice. Easy practice, you guys. Let's print out the shape as well. Here. Do .shape. There we go. Reprint. Okay. Okay. So there it is. Yep, 128 dimensions. Just shape. I can't make the sense of the raw numbers anyway. I know. I figured as much. I figured. Seek Haru. Yeah, exactly. All right, so 32 by 128, which is the number of dimensions. 32 batch size and 20 sequence. So we've got 20 tokens. We're going to batch to 32. So batch token dimensions. So attention is fine. That works. Hey, that's good to hear. All right, Neva, thank you. Maybe your NLP layers or the norm reduces it down at a dimension. It does. Okay. So here's our forward. We do our QKB projections, attention, and then our norms. Then we get an output projection. The output projection turns it into the dimension of the vocabulary, the number of tokens, essentially. The total token population. So you're saying it's around here, that's the problem? So we could say print out.shape here. We'll print a whole bunch of shapes on every one of these. Yes, sir. Clanker plays. Good to see ya. All right, we'll print them all. We're printing them all. Okay. So how about this? All right, we'll say forward. And we should get a whole bunch of shapes. Okay. Right there. So is my linear projection no, I don't. I feel like it's right. It's possible that I need my output. Why? All right. So what we could do is I think our targets need to be updated. Your transformer is right. Hey! Oh, nice, Neva. Thank you for saying. Oh, that's such a good, happy feeling. The target's the issue. Hey, we figured it out together. Neva, look at that. Neva, thank you. Thank you for the confirmation. It should be 3221. All right. I know how to do it. All right, Neva, thank you. All right. So it was our data preparation batch. Here we go. Let's get into it. It's a prepare batch. It's down here. Prepare batch. Here we go. Okay. Targets here. So I think what we need to do is this +1 plus 1. How about that? Sounds expensive? It's actually cheap. You can do this. Knowledge is for free. It's for free. And the compute, it can run on your phone. Oh, this is great, Neva. Thank you. All right, so let's see here. Did we do that right? 0. Whoa. 0. There we go. So, target. Yes, okay. How about this? 30, 20. Wait. 2D, not 3. Wait, hold on. Okay, that's good. Is it good? We're good now? So targets is good? It looks okay. I would like to print that. I'm gonna print the targets really quick. Let's do print targets. See what that looks like. Yeah, all right to me. All right. Look at that right there. Okay. You just need to project it 32, 20 to 1. Oh, so how do we project it up to 30, 21? Okay. A simple is enough. Okay. So is that what the reshape is going to do? Let me double check here. No, that won't do it. Let's do what you said. All right. Colon. Oh wait, colon, comma. Colon, comma, none. Like that. Let's try it. Okay. Too many colons, maybe? Hey, there we go. Look at that, Neva, right there. I see it. It makes sense. 2, not 3. 2, not 3. What's up, guys? Hey, Oxnell. Thank you for saying hi. Neva, this might be it. Check it out, you guys. All right. Thank you, Neva. All right. Let's see if we get our loss. Let's see if the loss works. Let's see if it works. Here we go. Moment of truth. Can also be written as an unsqueeze. Oh, yeah. Let's do that. Let's do that real quick. Before the moment of truth. Before we make it work. Let's do an unsqueeze. Let's do unsqueeze. All right. So you said unsqueeze, like unsqueeze 2? Unsqueeze 2. All right, let's try it. All right, we're learning things. Yep, there we go. Unsqueeze 2. Neva, you got it. All right. Here we go. Moment of truth, you guys. Moment of truth. Did we finally make it work? Oh, no. Oh, darn. Okay. Expected target 3285, but got 3221. Really? But I'm using... I thought it was good. It's a token. And it looks like it should commute. Oh, wait. I was dumb? Oh, you were? Oh, wait. Why? Wait, really? Unsqueeze should be a 1 hot. This whole time! We could do that. I got rid of it. All right, so good news is I didn't get rid of the 1 hot. I did not get rid of it. So we tokenize the targets, or do we just 1 hot? I think 1 hot automatically, so 1 hot. Did I delete it? I deleted it. Don't worry, I think I've got it right here. 1 hot. There it is, okay. All right, I've saved it. You guys, I saved it. Just doing inline 1 hot, that's way easier. Is it? So I have I wrote one myself. Set paste right here. Well, it's right there. It's not really like I wrote that. You can see it's right there. Okay. All right. So I'm going to save that. So we want to, do we still want to unsqueeze it? Where do we want to 1 hot it at? Dictionary.1 hot. Let's see. Yeah, like just torch 1 hot labels. Yeah. Here, how about this? All right, so let me redo, undo, torque, so let's hide that for now. Dictionary.1 hot, and let's see where we got on the shapes here. Let's see what here. No. Here we go. Looks good. Instead of proof the unsqueeze. All right, 1 second. Let's see what we got. Let's see what we ended up with here. Oh, there we go. That looks like the right shape to me, doesn't it? Yeah, right there. All right. Looking good now. I think so. Okay. Can we start training it? Does that look good? Did we do it? Criterion targets. All right. Moment of truth. It's the right shape. Oh, come on. No. Wait. Come on, really? It's like the perfect shape. Look, the targets and 82. Oh, whoa. Oh, wait, we got a problem. You need positional encoding for it to work. Okay, yeah, that's a good point. Okay. Well, PE, we forgot that we have this problem here. And it breaks here. It breaks right there. All right. The size of tensor 20. All right, because that's that. Was there a reason why? Was there a reason why I set it to 20? I don't know. Here, 32. Let's put this back to 20. Okay. All right. Expected floating point type for target with class probabilities and got long. Okay, so here. 1 hot. 2 float. How about that now? What if we did that, huh? Are you good now? No, Steven, you need to put it as your 20s. You're hiding a bug. Yeah, I'm definitely hiding a bug. I know. All right. Well, it's something. Just leave it as 32. Okay. Batch size 32. Okay. All right. So somewhere in our logic, we've got a problem. The size of tensor 20 must be match the size. Oh, is it because... Well, actually, I don't know. So, PE... Okay. So, my positional encoding is here. Window 20. Window. Oh, yes! Okay. So you're probably making it batch size instead of a window. Yeah, that makes sense. Okay. Yeah, that's probably what's going on. Okay. Well, here, I'll tell you what. We do got to wrap up. We got to wrap up because I've got a bunch of stuff that's happening around me right now that I have to head out for. So what I'm going to do is I'm going to git commit, git status, git add custom, unsqueeze the 0 position encoding would fix it. Wait, unsqueeze 0, the position encoding. Okay, we'll try it. So right here, you saying? SQUEEZE 0, like that? Okay. Custom. The size of tensor 20 must match the size of 32. Okay. Well, we found a problem though. We found a problem. So the shape that it needs to be needs to match the dimensions of every token. So say if we have 128 dimension of a token and then we're applying it over our window. Oh, that must be it. Okay. So right around here. Okay. Right around here. Okay. Here, I'll tell you what. We're gonna commit this, and then I have to go. I have to get going. All right. Git status. Git add. Yeah, you should be 3220 hidden. Okay, got it. All right. So I'm gonna write that down. It'll be, you said 3220 hidden. Okay. Indent that. All right. Git commit am. All right. Almost there. Let's see. Push to main. Boom. Done. All right. Thank you everybody for joining. We're heading on out. I gotta go. Got groceries at the door and a bunch of tasks that I gotta take care of and other things that are happening. But I had so much fun, Neva. Thank you. Thank you, Neva. We got a lot closer. We're almost there. Almost there. We're so close. Thebian, Beast Huntery. Hey, Ted. Copilot increased the price. Oh, wow. Really? That's crazy. Neva, thank you so much. You helped me a lot. That's great. I appreciate it. We're having a lot of fun, you guys. All right, we'll be back tomorrow, and we're going to finish this. We're going to finish this. The weekend is like, we got to finish it this weekend. We got to. We're so close. We're so close. All right, you guys, thank you so much for joining. Bye, everybody. Have a great weekend. See you tomorrow.